Hello people. As you know, I am Srihari from CurioSphere, here to clarify your doubts in physics and mathematics. Okay, so this is a continuation of our demo session. Today we are going to see 10 more questions with a little more of a difficulty, focusing more on advanced questions and Olympiad-like questions. Okay, after this we can see actual advanced and Olympiad questions, but for now, similar to those levels we will see. Okay, as I said, we will go through the question and go through the corresponding concept side by side. Okay, so what are the three things I told you is required for solving any question? Do you remember? First, you need to know what is given, then what is asked. If you find these both, these are the endpoints, you can find the connecting concept. Okay, you can find the connecting concept and hence the formula which is required to solve the question, right? And as I said, in some cases there can be one concept, in many places there can be many concepts, right? Especially in advanced level and Olympiad level questions. Okay, in such cases you have to connect between the concepts. Okay, without any delay we will go through the questions. Right, now radioactive sample initially has 1 gram of substance A. It is given it is 1 gram of substance A. After 2 hours only 0.25 grams remains. What is the half-life? So this is given. This is given and this is asked. How do you find what is the concept behind it? They have given it is a radioactive sample. So it is a radioactive decay. Decay. And what did I tell you about radioactive decay reactions? They are all first order reactions. They follow first order kinetics. Okay, so we use the first order kinetics formula. T is equal to 1 by K ln A naught initial amount by A naught minus X. The typical time formula for a first order chemical kinetics reaction. Okay, first order reaction. Here they have given the time, it is 2 hours, right? The time it is given as 2 hours. Wait 1 minute. Time is given as 2 hours, right? And the rate constant or the reaction constant, we have to find out. Ln initial amount is what? 1 gram in 1 by 1 minus. Always remember this X is the amount decayed. Okay, it is the amount decayed. So how much it is decayed? 0.125 it is remaining. Okay, 0.125 it is remaining means how much it has been decayed? 1 minus 0.125. Actually, you need not do all this. See, A naught minus X. X is what? How much it is decayed. A naught minus X is what? How much it is remaining. So you can directly substitute A naught minus X with 0.125. I hope you get it. X is how much? X is what? It is the amount decayed. So what is A naught minus X? The amount remaining. And they have given the amount remaining 0.125 grams. So we will write that here. 1 by 0.125. Okay, so if you cancel you will get 8 times, right? So K is equal to, or keep it as I said, keep it as 1 by K because you need to substitute it directly. So 2 by ln 8 is equal to 1 by K, right? Keep it aside. This is our first relation, right? And now they are asking what is the half-life. Half-life means T will become T half. t will become t half equals to 1 by k, and x will become a naught by 2. A naught minus a naught by 2 will be a naught by 2. So a naught by a naught by 2, it will become 2. A naught will get cancelled. So the numerator 2 will come. So it will be ln 2. I hope you understand. Just substitute x with a naught by 2 for what half-life. Okay. And t half, it is here. 1 by k is what? 2 by ln 8. 2 by ln 8 and into ln 2. Now ln 8 can be written as 2 by 3 ln 2. Right? 8 can be written as 2 cube, and the 3 can be brought outside of the logarithm. You will get ln 2. ln 2 will get cancelled. It will become 2 by 3. Is it hours or minutes? 2 by 3 hours or minutes. Here it is given hours. You should be very careful with the units. 2 by 3 hours. Now, is there any 2 by 3 hours? No. It is given in minutes. Some options are given in minutes. So we will check it converting into minutes. So 2 by 3 to convert into minutes, we multiply it by 60. Two by 3 into 60. It is equal to 40 minutes. So which is option B. Okay, it is option B. Option B is the right answer. Now you may think it's a very long process. Okay, it is a very long process, but I'll tell you there is a catch. There is a shortcut formula for this, right? N by n naught equals to 1 by 2 the whole power n. I think you remember this formula from the previous set of questions. We used the same formula to find the number of half-lives in a given reaction. Right, remember the 30 minutes question? Wait, I'll show you now. Where is it? We saw a question, right? 30 minutes, 90 minutes, how many half-lives are there? I think it's 1 by 8, that thing question. Yeah. See, the question, radioactive substance has a half-life of 30 minutes. What fraction of 90 minutes? Like what fraction remains after 90 minutes? We have to find the total number of half-lives in the reaction, and 1 by 2 will be the fraction remaining. Okay. So how does 1 by 2 come? That's what we are going to see now. This is the formula, and yeah, if you substitute what n by n naught, wait, after 2 hours only 0.125 grams left. First, initially how much gram it was? N is what? 1, and how much it was left? Sorry, n naught is what? 1. How much it was left after some time? 0.125. Okay, 1 by 2 power n. Okay, now n naught, so it is 1 8, n is equal to 3. 1 by 8 equals to 1 by 2 the whole cube. So n is equal to 3. There are 3 half-lives contained in it. Okay, there are 3 half-lives. There are 3 half-lives contained in this 2 hours. You get the point now? After 2 hours, we are taking the amount which is n remaining, 0.125. So within the 2 hours, we are finding how many half-lives are there. So we have, within the 2 hours, we have 3 half-lives. Okay. Within the 2 hours, we have 3 half-lives. Now, just use the unitary method now. In 2 hours, there are 3 half-lives. Okay, we need what is the only one half life? How many hours? So x equals 1. So 2 cross multiply, you will get 2 is equal to 3x. X is equal to 2 by 3 hours will be 1 half life. 2 by 3 hours will be 1 life. See, we got it in the simple steps. We got it in very simple steps. I hope you get it. It's a very simple. N by n naught is a fraction of nuclei left behind. Okay, the remaining. Okay, and within the 2 hours we are finding the fraction of this remaining, that is 0.125 by 1 they have given. Now finding how many half lives are there, we get it to be 3 half lives are there within 2 hours. Within 2 hours if there are 3 half lives, then within how many hours there will be 1 half life. So you're using just a common basic math of unitary method we are using and finding 2 by 3 hours, and 2 by 3 hours nothing but 40 minutes. I hope you get. But how did we get this n by n naught? Okay, how did we get this n by n naught? There is another question, I think it's question number 17, where you need to use this. Okay, at that time I will tell you about this. Okay, now for now we'll move on to the second question. Second question, the hydrogen atom. Okay, the hydrogen atom transition from n equal to 4 to n equal to 2. What is the wavelength of the emitted photon? Now remember the Rydberg's equation. Yesterday we saw, right, from Bohr's postulates. Rydberg's equation, it says nothing but 1 by lambda is equal to 1 by lambda is equal to Rydberg's constant into, always have it in the mind, this Rydberg's constant, then the energy, that E naught, everything, we are assuming that this nucleus is stationary and not rotating, only the electron is revolving around the nucleus. They are not there, it's not a two body system revolving around common center of mass. Okay, that muon question, we did it because we had muon in place of an electron which is much more massive and used the reduced mass concept. In other cases we just normally ignore the movement of the nuclei. Okay, now coming back to the Rydberg's equation, tell me what will be the Rydberg's equation. 1 by n out or inside, n out or n in square minus 1 by n out square. Always have this in mind. You don't be like n final, n initial, it will be confusing. Whatever outbit is inside, you put it first inside, n1 by ni squared minus whatever orbit is outside, 1 by n outside, out square. Okay, and 13 point sorry, not 13.6, it is z square. Since it is hydrogen, it is 1. Okay, now 1 by lambda equals to r into, what is n in? It is whether it is moving n is equal to 4 to n is equal to 2, or n is equal to 2 to n is equal to 1. Sorry, n is equal to 2 to n is equal to 4. Only the sign changes. Energy is either lost when it is moving from higher energy to lower energy, or it is gained from lower energy to moving from lower energy to higher energy. You remember? But wavelength will always be positive because length it cannot be negative, right? So you have to remember that. 1 by, which is n2 square minus 1 by 4 square, you will get what? R 1 by 4 minus 1 by 16. 1 by lambda is equal to, wait, R into 3 by 16. If you do it, you will get lambda as 16 by 3r. 16 by 3r, right? If you compute by substituting it with the value of r, I think some of the values, I think we should give the values of r and all, but if at all they didn't give, so it's better some standard values like gas constant, so this one R, Rydberg's constant. Chemistry, many constants will come, like the what to say, the universal gas constant, as I already said. Then the gravitational constant in physics and everything is better. Some of them which you see often in the questions, you remember. Okay, especially the gas constant is very important. Okay, now if you compute this by substituting the value of R, you will get 486 nanometer. So the answer is 486 nanometer. Okay, in exam you have to compute it, but yeah, 486 nanometer. This is from what? Which concept? Bohr's postulates of Rydberg's equation. Bohr's postulates model wheel, right? Which is the formula we use? Rydberg's equation. Right, it's a Rydberg's equation. Now coming to question number 13. Right. The mass of a nucleus, assertion, right? Sometimes it may go very tricky. This is a J Advanced 2020 question. Okay. The mass of a nucleus is always less than the total mass of its nucleons. The mass difference is converted into binding energy. Right. So is the assertion true? The mass of a nucleus is always less than the mass of the nucleus. Yes, it's true. We saw, according to Einstein's postulates, this is an observational thing we did. We saw yesterday, if you remember. It is true. The mass difference is converted into binding energy, which is also true, according to Einstein's postulates, and E is equal to mc squared. Now, this is very important. If one statement is true, other statement is false, then it is very easy to choose the options. But if both comes to be true, it is now you have another trick. You have to find whether the reason given correctly explains the assertion. Right? Sometimes both may be true, but the reason can be completely different and assertion may be completely different. They need not explain each other. Right? So, first option, the mass difference is converted into binding energy, and that is why that is correct. The correct reason because the mass difference is converted to energy, the total mass is less than total mass of the nucleus is less than the total mass of the nucleons. Is that so? Does the reason explain assertion or the assertion explains the reason? Think carefully. Think carefully. Wait. See, because think experimentally, we find the mass of nucleus is less than that of nucleons. Then we find where is the mass defect going. The mass defect is converted into energy. In that case, if you see, because there is a mass defect, that mass defect manifests itself as a binding energy. In that way, if you see, then you should choose option B. But if you see in the other way, that is, because there needs to be some energy that requires for to be there present to bind together the nucleons, there should be the mass defect hence happens. For binding energy should be present. For the binding energy to be present, there is a mass defect, and hence because of the mass defect, the total mass of the nucleus is less than that of the total mass of the nucleons. In that way, the other way around, if we think, we should need to choose option A. So which one we should go about? Experimentally thinking, first we find the mass defect, but the other way around, if we think, we should choose option A. So what do we go with? I go with option A only, because I think nature has to do something with always a reason. So in order to have a binding energy only, it has created a mass defect. So it may be too philosophical, but still I'll go with option A. Right? You can argue with this question as well. Let me know if you have any other opinion about this question. Okay. Now moving on to the second, fourth question, 14th question. The energy of the photon emitted in transition in He plus ion from n is equal to 3 to n is equal to 1. It's the same Bohr's concepts. H nu, the energy of the emitted photon, is difference in energy of the outer minus difference in energy, difference in energy is between the outer and the inner, or from where it is going, because it is emission. Right, you just need to subtract the differences in energies. Okay, and since it is He plus ions, a hydrogen like ion, we can use Bohr's model. That is no problem in it. Okay, the energy of photon emitted in a transition in He plus ion from n is equal to 3 to n is equal to 1. Okay. Now coming back, let's solve this. Energy of photon, they are not specifically asking frequency, so we just have to replace it by E and all, E with E. And what is E out? Minus, this pen, it is, sorry, it's first time writing with this pen, 13.6 into Z squared. It is helium ion, so Z squared 2 squared, it will be 4 by n squared. First E out what? N is equal to 3, 9 minus of minus 13.6 into the same 4 divided by n is equal to 1. Right, now adding all this, minus 13.6 into 4 by 9 plus 13.6 into 4 plus minus into minus becomes plus 13.6 into 4. Now if you compute this, you will get E is equal to, let's put it in the calculator, 13.6 into 4 minus 13.6 into 4 divided by 9, 48.34, right? It becomes plus 48 point, wait, 48.3. Okay, 48.3. Sorry, with this pen. Okay, please adjust it 48.3. Let us see the options. Wait, there are no options matching. Did we do any mistake? It's electron volt only, so it's anyways electron volt only. Let me see. Electron volt. Yeah, there's no issues with Newman. What are they asking? Energy of a photon, which is E only. Difference in the energy levels, which is only what have we done? Right, it's Z square by n square. So minus 13.6 square. Z is what? Helium, it is 2. So 2 squared is 4. N is what? N is equal to 3 for the first case, 9. And n is equal to 1 for the second case, 1. So yeah, everything is fine, guys. Everything is fine. I think there is some mistake in the options. In the last, I think it should be 48.3. So however our answer is 48.3. That is correct only. 48.3 electron volts. Well, the question ends here, but this question leads us to a beautiful concept. Now, we are saying the energy of a photon, we can equate it to h nu. E is equal to h nu. But how? How? Who gave this formula? It was Planck. Right? It was Planck's quantization theory. Let us see a brief thing about how this formula came up. Okay, so it started with the black body radiation, right? The black body radiation, normally black body radiation, right? So what is a black body? A black body is nothing but a body or a substance. It's not necessarily black, actually. It is a substance which absorbs all wavelengths of light, not wavelengths of light or EM like electromagnetic waves, all wavelengths of the EM spectrum. It's a somewhat very safe to say light, because we only see the light spectrum, right? Visible light of light, right? And emits only certain wavelengths, depending upon its temperature, depending on the temperature of the substance, depending upon its temperature. Now, without going delve deep into this black body radiation part, I hope you will learn it in some other lesson. I don't exactly remember which lesson it is, but yeah, you will learn it. But now let's see briefly how this black body radiation led to this formula. Okay, led to this formula. Now, there was a problem with the classical theory. So a few scientists, they were involved in this classical theory, actually, right? Let me name them. It was Rayleigh-Jean's law, the classical prediction. It predicted the Rayleigh-Jean's law. You need not know them, but yeah, just for information, Rayleigh-Jean's law. Jean's law. It stated that whenever the wavelength is decreased, right? Whenever the wavelength it is decreased, the emission, how to put it in the background? The energy emitted becomes more and more. Like, the energy emitted is inversely proportional to the wavelength of the light incident. Like wavelength of the electromagnetic wave that is incident on the black body, right? That is incident. Let us keep it more simple. For example, a wavelength strikes the black body and it re-emits a set of wavelengths, a pack of wavelengths. Strikes the body, a black body, and it re-emits certain wavelengths. In what way it re-emits? For example, this is a black body. Assume this is the black body, and there are many waves coming, 3 waves coming. This wave has the lowest wavelength, and this wave has the highest wavelength. Okay, so what this law, the Rayleigh-Jean's law, says is that like all the waves get re-emitted. Sometimes only one wave or 2 waves get re-emitted, but let us it depends on the temperature of the black body. But now let us assume this wave and this wave is re-emitted. The second wave is not re-emitted, it is absorbed. Okay, second wave is it's absorbed. This has a smaller wavelength, this has a larger wavelength. Okay, now what this law says is that the the first ray which has the larger wavelength, the first wave which has the larger wavelength is re-emitted with a smaller energy, okay. And this second wave, which is the third wave actually has a shorter wavelength but re-emitted with a larger energy. That's how this law predicted things. But there was a problem. Okay, so we all know the electromagnetic spectrum, right? It is visible light in the center, then this side the ultraviolet, the UV rays, then what is it, the higher energy. As we move towards the right, the frequency and the wavelength changes. The radio waves having the highest wavelength and lowest frequency, and the gamma rays having the lowest wavelength and the highest frequency. So in that electromagnetic spectrum, right, the ultraviolet, there was an anomaly called ultraviolet catastrophe, right? Catastrophe, because the wavelength of ultraviolet is less than the visible light. Okay, so the wavelength is less. According to this law, it predicted that when an UV ray strikes a black body, since it has very less wavelength, the amount of re-emitted wavelength, it has infinite energy. You get it now? When ultraviolet strikes the black body, it is get re-emitted with infinite energy. But that is not possible. Whatever is happening with the experimental data, it is not matching. So sir, there is some problem with Rayleigh-Jean's law. So that is what Planck understood, and he took a bold move. He observed that the Rayleigh and Jean's law considered energy to be continuous, that they could take any value depending upon the frequency of the waves. Okay, frequency of the waves. But Planck made a bold move and told that energy is discrete. Yesterday also we saw energy is discrete or quantized. Meaning that it can take only specific values. In case of atomic structure, it was multiples of h by 2 pi, which is nh by 2 pi. The angular momentum should be multiples of h by 2 pi, where h is the Planck's constant. Okay, energy is quantized. And what Planck did, he told energy is quantized, but it quantized on what? What is the basic unit he need, so that other energies can be told as a multiple or a a greater factor than this basic unit. It is similar to a measurement. We say 15 centimeter. Centimeter is the unit and 15 is the magnitude. Centimeter unit is used to standardize the value, and 15 is the magnitude. How many times 1 centimeter makes the scale or the length of the scale. Is similar to that. It is similar to the measurement thing. See, in physics, every concept, a small atom to the large universe, they are interconnected. They are similar how they work, known physical laws. Okay, so that is the beauty of physics actually, right? Now, so he said energy is proportional to the frequency of the wave. Those times people were working with oscillating charges, and they observed more the oscillating charges, more frequently they are oscillating, they provide more energy, right? They produce more energy. So they came to conclusion, the Planck at least came to conclusion, that energy can be directly correlated with frequency of the wave and can be used as a basic unit. Okay, it was dimensionally also it was very helpful for him, right? Why did not he use the wavelength? There are only two characteristics for a wave, it's wavelength and frequency. But why did not he use the wavelength? according to him, the frequency was more accessible term to relate to the related to the energy. It's more accessible, meaning it can be uh, more easily studied, right? So he used frequency rather than the wavelength, and he directly what correlated it with frequency, and to make it an equality, he used a constant of proportionality called h, and this constant of proportionality is known as Planck's constant, right? This is known as Planck's constant. This one simple formula changed the way physics works, right? E is equal to h nu. E is equal to h nu. So it's all started with the black body radiation and ended up with energy being correlated with frequency of the wave, right? And now you have to remember this because this is important and it will come further in a few other concepts as well. Okay, so now let us move on to the 15th question. The next question, which of the okay, we solved it. Yeah, which of the following has the shortest de Broglie wavelength for the same kinetic energy? And yeah, I told you it will. The Planck's theories will be useful for the further thing. Now it is being used for de Broglie wavelength, right? Now, before delving into this concept, let us go to what our new scientist de Broglie thought. De Broglie, right? De Broglie. After Planck came up with this quantization stuff and everything, there were many observations being made about radiation having dual nature, such as both wave nature and particle nature. Light undergoes reflection, refraction, interference, everything. All has its what? Wave nature. Light undergoes photoelectric effect, Compton effect, everything. It says light has also particle nature. So it's a wave particle duality. Okay. What de Broglie thought? If light can have a dual nature, why can't matter? Right? Why can't matter? So this was his curiosity, and he tried to find a relation between normal matter possessing a wave nature as well as a particle nature. So he thought, for a wave, what is the characteristic feature? Lambda is wavelength and the frequency. For a particle, there are many features, but there are like momentum, speed, acceleration, stuff, everything for a particle. So he thought to show matter has a relation to dual nature, he need to find a relation between these two. Only then he can find prove his idea. So what he did was that from the Planck's theories, from Planck's theory, E is equal to hf or h nu, whatever you may call it. I will use hf for now. Planck is relating frequency of the wave with this energy, and energy is the same for everything. Energy is energy, be it a radiation or a matter of stuff, potential energy, everything. Energy is indestructible. Yeah. So he used that idea, and he came up with the formula lambda is equal to h by p. Now let me tell you how he came up with this formula. Now here comes the intellect of Einstein. Einstein's famous equation, E equals to mc squared. What? E is equal to mc squared hf. Wait 1 minute. hf E is equal to mc squared. Now can you see the connection between these two? hf m mc squared. Einstein correlated energy and mass. Mass is a what to say? Mass is the characteristic of a particle, a matter, and Planck correlated energy with the frequency. What is frequency? An attribute of a wave. So these both energies are the same. Energy is energy, as I said before. So what de Broglie did, to connect a matter and a wave, he used energy as a common point. So this he took from Planck and this he took from Einstein and told, okay, let me see, hf is equal to mc squared. Hf, f is a frequency, attribute of a wave, mc squared, m is a matter, a mass, attribute of a matter. So yeah, now I have created a relation between a wave and a matter to say not only a radiation but matter also undergoes wave particle duality. Now refining this formula further, f can be written as c by lambda. C is the speed of light. mc squared, mc squared, it can be written as mc into c, right? Mc is nothing but the momentum of the particle. Ideally it is not moving at the speed of light, but for now let's assume it is moving at the speed of light, p into c. Wait, I'll write it here. This implies hc by lambda equals p into c. Cancel c, you will get lambda is equal to h by p, right? H by p. Now let me say, this p here may not always mean the particle is moving at the speed of light, because no particle can move at the speed of light. According to Einstein's postulates, if a particle moves at the speed of light, it becomes energy massless. So mass will become zero. At least according to my knowledge. Maybe there may be new theories I do not know about. Let me study about those in detail and come to you. But for now, this p, lambda is equal to h by p. This lambda is known as the de Broglie's wavelength. De Broglie wavelength. And this is nothing but our Planck's constant. Right? And p is the momentum of the particle. See, this lambda is the attribute of a what? A wave. This p is attribute of p is nothing but momentum of a particle. Right? So yeah, what it says, what is the meaning of this thing? You have to see the importance and the relevance of this formula. It is very, very interesting. Now you may think, for matter, if it has wave and particle duality, then why don't we human beings have a wavelength and we have only a mass? Why do we have a wavelength? You have to be very clear that this formula is at a very microscopic level. That is, our mass is a macroscopic when compared to atomic masses of subatomic particles, right? Subatomic particles. Now, you see, lambda is inversely proportional to momentum. Lambda is inversely proportional to mass into velocity. Okay. So, our mass m, our human beings, it is huge compared to subatomic particles, those of subatomic particles or atoms, right? So, as our mass is so high, our wavelength is so less that we are unable to see V moving. The wavelength is so less such that what I mean to say is our wavelength is negligible. Even though we have a wave nature, we are not able to perceive it because we have huge mass, right? And the same way, this momentum, if the velocity increases to an extent to the speed of light, then also the particle will, the momentum will become infinite till the momentum will become very high and the wavelength will decrease so much. So even when the particle moves the speed of light, its wavelength decreases. But here you might think, when it becomes when a body moves in the speed of light, it becomes energy and there is no mass in it. Then if c is very high and mass is nearly zero, then that should balance. Well, even I have the same doubt. Maybe our doubt itself is somewhat out of confusion. Let us explore that together. If you have any insights, please let me know. So for now, this is our formula, lambda is equal to h by p. And for momentum, we know already there is a one formula. Kinetic energy is equal to p squared by 2m, right? Wait, where is it? Yeah, kinetic energy is equal to p squared by 2m. Now p is equal to root over 2mk. K is the kinetic energy. And now we use, because in this question they have given 4 particles and we know only the relation between their masses, right? We know only the relation between their masses. We don't know what is their kinetic energy and stuff. I mean, like, what is the momentum and all, right? So we are using lambda is equal to h by lambda is equal to, actually this concept is a de Broglie wavelength concept. Everything comes from dual particles, a dual nature of light. The previous chapter, but you know, everything is connected, interconnected. I don't know if you have seen this web series from Netflix. It is called The Manifest. It's about a plane coming after you see, you will understand. It is very interesting. It says about wormholes, time loops, everything. It's quite interesting, and there they say it's all connected. Like that only. In physics also it's all connected. Yeah. Now moving on. It is lambda is equal to h by, instead of p I'm writing root over 2mk, kinetic energy. Now they have said, you have to notice here. This is the given. This is why you have to notice the question very carefully. It has the same kinetic energy. So we rule out the possibility of kinetic energy because everyone has the same kinetic energy, and h is already a constant, Planck's constant for everyone. 2 is also a constant, so we have to come to a conclusion that lambda is inversely proportional to the root of the mass. Here the root we need not worry about much because we do not require to magnitudically compare, or there is no other factor which changes along with m which affects lambda. There is only single factor, root over m. So root doesn't have any big effect. We can just say mass is inversely proportional to lambda. Okay, so higher the mass, lower will be the lambda. So what they have asked now coming what they have asked, which of the following particles is shortest de Broglie wavelength? So this to be shortest, mass should be the maximum. Now you have to see which particle has the maximum mass. An electron, we all know it has the least mass, almost lightest particle. A neutron and a proton has almost the same mass, while neutron has a slightly greater mass. An alpha particle is not a single subatomic particle, but is a helium nuclei. So obviously it will have the highest mass. So which is the right answer then? It is the alpha particle. Yeah, so this question is done. You may think all these are very easy questions. Then I already know de Broglie formula, everything. But did you know about this relationship between Planck's theory and de Broglie's theory? This is the beauty of doing simple questions along with concepts. When we go to highly conceptual questions, highly complicated questions, these concepts help us to solve the questions. There we need to use a different kind of a mindset. Okay, we'll get to know as we solve it, so no issues. So yeah, moving on to the next question number 60. Which of the following reactions releases energy? Okay, so this is a typical, which is the following is the exothermic reaction question, right? Similar to chemistry. You need to know one thing. Energy, law of conservation of energy. Energy can neither be created nor be destroyed. Okay, energy can neither be created nor be destroyed. So it can only transform to another. In the reactants and the product side of every reaction, the reactants possess some energy, the products possess some energy. Okay, the reactant side energy will be released, the product side the energy will be released only when reactants have a higher energy when compared to the products. It means, for example, I have 10 bucks. I have 10 bucks with me, and I have lost 2 bucks in some theft case. I have in some theft somebody stole from me. I have lost 2 bucks and I'm giving him only 8 bucks. So in order for me to lose some amount, I need to give only 8 bucks to him. 2 bucks, like what do you like, how you get it right, how to say it, like only if I have a higher energy I can afford to lose some amount of energy. So in every reaction you have to see whether the reactant side has a higher energy compared to the product side, so that energy is released, right? Energy is released in the reaction. This is a NEET 2020 question, and remember guys, this is an Olympiad level. It is this question, the previous question, INPHO, International Physics Olympiad. This is 2020 question. You may think it's a very simple question, why are they asking in Olympiads? But see the amount of concept behind this question. Black body, we went to black body radiation also. This is the beauty of reading or researching between a concept, inside a concept. So if you are willing to do such researches, you can join ISIS. They are really good for them. Okay. Yeah. Now coming back to question 16. Question 16. Which of the following reactants releases energy? Right. First option. Let us check first option. Uranium 235. Okay. Giving out 238. So you see the mass number is increased, right? The mass number is increased. What happened? Oh. Uranium, the mass number is increased, which means there is increase in the number of protons or the number of neutrons. Okay. So what did I say? We have a energy binding. To hold the binding energy should be there to hold the neutrons and protons together. So when uranium 235, which has only 235 neutrons plus protons, it increases its amount to 238 nucleons. It needs lesser binding energy or more binding energy to hold them together. It requires even more. It is just like handling 10 students in a class requires less effort than handling 50 students in the same class. So you need more amount of teachers, which is the binding energy in this case. You need more amount of teachers to handle more number of students. So you need to put in the resource. You need to put in the energy, binding energy. Okay, so in this case energy will not be released. In fact we require more energy. I think it's endothermic reaction, but I'm not sure. So it's definitely not option A, right? It's definitely not option A. Now fusion of helium nuclei. Okay, one thing you have to be very clear: both nuclear fission and nuclear fusion reactions are exothermic reactions. Both release energy. That is the beauty. Many think fusion absorb energy, fission reduce energy. No, both release energy. And there is a beautiful reason why. Let me tell you it in the upcoming questions. Okay, let me tell you in the upcoming questions. So the fusion of the nuclei. So as soon as we see fusion of nuclei, okay, it requires more energy for fusion to happen. So we need we need not consider it. No, it's not like that. The fusion of helium nuclei, we need 2 nuclei to fuse. Helium 4 plus one another helium 4 gives out what is atomic number 8? Okay, I'm not sure with this equation. Let us keep this. We'll check other options now. Now this is the point. When you what cannot test or check an answer, check an option, you move on to the other option, try eliminating those options. Okay, you need not sit and check the option whether it is correct or not. Just eliminate it. Just eliminate it. This is for exams, right? If you want to know more about it, you can, after the exam, you come and sit and you can get to know more about it. Okay, this is another one more trick we can use it. Okay, it's very common, everyone knows it, but still I'm saying. Now fission of Fe. Now you might think fission of Fe, it releases more energy because fission happens more readily, but no, not in case of Fe. Do you know the binding energy chart? The binding energy chart, binding energy per nucleon, it is maximum for Fe. This is binding energy per nucleon. This is the atomic number of elements. It is maximum for Fe56. It is used, you mentioned Fe56. So it is maximum, binding energy is maximum, meaning that among all molecules or nuclei, iron molecule has the highest binding energy that is holding its nucleons together. So in order to break that binding energy, we need a very high amount of energy so that the nuclei is split. So that is not a feasible reaction, right? So it does not undergo fission readily. We have to apply a huge amount of energy. It again becomes an endothermic reaction, more or less endothermic reaction. Of course, if fission undergoes, it will release energy, but it is not a spontaneous reaction. Spontaneous reactions, non-spontaneous reaction, thermodynamics. Do you remember? Yeah. No, so it's not option C also. Now coming back to option D. Now you have to watch it closer. Option D, they have given a reaction. Option B, they have given the equation itself, they have given in option D, but in option B they have not given the equation. Just they have given fusion of helium nuclei. That's it. Okay, just they have given the helium nuclei fusion. But in option D they have clearly given the reactant in the product. Now actually if you see the reaction is like hydrogen plus another hydrogen fusion, undergoing fusion together to form a deuterium ion, deuterium nuclei plus energy. This will sure release energy, but here in this reaction there is one hydrogen nuclei missing. Hydrogen nuclei missing. So this reaction is not feasible. Feasible reactions, yeah. This reaction is not feasible. Okay, so we should not consider this option. So the answer is option D. Option B. Now that we have found the answer, let us know what is the fusion of helium nuclei reaction. Fusion of helium nuclei reaction. Okay, it seems not two helium nuclei but 3 helium nuclei fused together to give a carbon-12 atom. It's because carbon-12 is more stable in nature, so helium, again another more helium, it will give carbon-12 plus energy. See, it releases energy. Now that you eliminated the options, you got to know the correct answer. Then out of curiosity you are finding out, because it's not just about curiosity. In future the same question, sometimes it happens, JEE mains question can get repeated in JEE advanced as well. In that case they won't give you options. What if it's a numerical type question or descriptive like assertion reason question? That time you'll get stuck. So at that time what will help you? Such deep studies of each question will help you. So after each question, after the test or the exam, go through every questions obviously. Whichever questions you have eliminated the options and found out the answer, especially those you have to check it. Okay, especially those you have to check it. Yeah, now moving on to question 17. Yeah, now comes the question 17, which I told you earlier that there is a concept behind n by n not equal to 1 by 2 power n, and I told you I will tell it to you later how the derivation came. Question 17, hence it comes here. It's a J Advanced 2019 question, guys. It's a J Advanced 2019 question. Right. Now come, it's a beauty of mathematics, differential equations. Any nuclear reaction, radioactive decay, radioactive decay is a first order kinetics reaction, right? First order kinetics, nucleus 1, just denotation, right? Nucleus 2, a radioactive decay, it is a first order reaction, right? Sorry, this, okay. First order reaction, and it is found out experimentally, right? It is found out experimentally that amount of the nuclei, the number of nuclei in a sample, they won't take a single nuclei and make it undergo radioactive. Because in nature we cannot isolate a single nuclei and do radioactivity reactions. It's very time consuming and energy or money consuming. So just take a sample in which there are thousands or millions of nuclei, right? Millions of nuclei. Then we perform radioactive decay. Yeah, what was I saying? There are a number of nuclei, thousands, millions of nuclei inside a sample. Generally, we take a sample. Okay, so according to the experiments, what they have been told is that the number of nuclei, the rate at which the nuclei get radioactively decayed is directly proportional to the number of nuclei present. Number of nuclei present. What does it mean? For example, initially there is n1 number of nucleus. So as the radioactive decay starts, the rate at which the radioactive decay happens is directly proportional to n1. After some time, the number of nuclei will become n2. The rate now will be directly proportional to n2. First it will be n1, then it will be directly proportional to n2, directly proportional to n3, and so on. All that it means is that at any instant the rate is directly proportional to the number of nuclei present at that moment. Okay, dn by dt is directly proportional to the number of nuclei present at that moment. And we use a negative sign inside it. Do you know why? We use a negative sign inside it because as the radioactive decay proceeds, the number of nuclei present, the total initial number of nuclei present will keep on decreasing. N1 will be greater than N2, will be greater than N3, and so on. So in order to represent the decrease in the number of nuclei, we use a negative sign. So now we have dn by dt directly proportional to negative of n. Okay, and to remove the constant of proportionality sign, we use a constant of proportionality, right? We use a constant of proportionality, that is nothing but lambda. Oh my goodness. Oh my god. Lambda minus lambda n. Now if this is a differential equation, we need a proper solution for this equation, so we bring the terms accordingly. Dn by n integrated minus lambda integral dt. It is from 0 to t. At initially t is equal to 0, let us assume there is initial amount of n naught, and at finally there is an initial amount n. Okay, don't confuse n prime you can have. Okay, or not to get confused, use this as n prime, dn prime n prime, just for avoiding confusion. Okay, there's no big difference, right? Now integrating dx by x integral is ln x, ln n prime. We are applying the limits. Okay, ln n prime, we are applying the limits n naught n minus equal to lambda t, right? T minus 0 is t. So ln n by ln n minus ln n naught is equal to minus lambda t, which gives ln a minus ln a minus ln b is nothing but ln a by b. So ln n by n naught is equal to minus lambda t. Keeping exponential or applying exponential on both sides, we get n by n naught is equal to e power minus lambda t. This is the solution of our differential equation. We will get a constant of integration, but here we are using definite integration, so there is no constant of integration. That possibility is ruled out. So this is our equation. N is equal to n naught e power minus lambda t. E power minus lambda t. Now, how we came with that n by n naught is equal to 1 by 2 the whole power n? Now let us say it's a very intuitive thing. That's a very intuitive thing. Actually, we can go behind with this derivation stuff still, but it's not required. If you want, you can just substitute for a t half. T is equal to t half, find the value of lambda, substitute the value of lambda again in the original equation, you will get the value. But let us not go, we go in an intuitive way. Okay, first n after t half becomes n naught. First you have n naught, right? N naught by 2. After again another half life, it becomes n naught by 4. This becomes half, and again this also becomes half. After another half life, n naught by 16. So after 3 half lives, how much it has changed? Now see, for after each half life, it is reduced by a factor of 1 by 2 whole power n. Do you notice? After first half life, it is reduced by half, n is equal to 1. After second half life, it is reduced by 1 by 4, 1 by 2 squared, n is equal to 2, because there are 2 half lives. After n is equal to 3, it is reduced by, I think it's not 4 by 16, it is it is by 8 actually, right? It's 8. So n by n naught is nothing but a fraction of molecules at any instant. Wait. 1 by 2 power n. Get the point? After each half life, the value decreases by 2. So it is exponentially decreasing. So it is 2 power n. 1 by 2 power n. I hope you got this intuitive idea. If you have any doubts, you can ask me. Right? No doubts, right? Okay, fine. Now we go. This is the concept of the derivation I was talking about. It's differential equations, guys. It's you trust me, differential equations are wonderful, actually wonderful. Okay, let's go. Now, what is it? The number of metal nuclei drops from n naught to n naught by E in 10 minutes. Then what is the decay constant? Oh, very easy question. See, we just applied this formula. N by n naught n naught equals to minus E by lambda t. Right, now see, if the number of nuclei drops from, first initially it was n naught, so what is now currently the value of n naught by E, here it is n naught initially, equals e power minus lambda, what is t? 10 minutes. Keep it as 10 minutes, no need to change it in seconds and all, because already the options are also in minutes only. N naught, so n naught will get cancelled. It will be 1 by E equals e power minus lambda 10 or 10 lambda, e power minus 10 lambda. Okay, yeah. Now coming this side, you can write e power minus 1 equals to e power minus 10 lambda. Now if we equate the powers on both sides, because the bases are the same, lambda is equal to 1 by 10, right? Lambda is equal to 1 by 10 minute power minus 1, because this 10 minutes comes to the denominator, right? Comes to the denominator, and it will be 10 minute power minus 1. So lambda is equal to We'll write properly. Lambda is equal to 0.1 minute power minus 1, which is option A. So yeah, this question has been solved. I hope this concept of differential equation and being directly proportional to n, you got it properly. Right, now going to the 18th question. Which of the following nuclei is more stable based on the binding energy? I think you know the answer. It's a Olympiad level question, guys. See, Olympiad level question, don't think it is so easy. Why are they giving so easy questions? No, it's not about that. It's about how intellectually you understand the concept behind it. No, it's a very factual question. Many books don't know, and many people know that iron 56 has the highest level of binding energy in the entire periodic table. At least according to what we study, it is iron 56 has the highest amount, right? But why? This question is for that, to know why iron 56. Okay. Hello, am I audible? I hope I'm audible. Yeah. Iron 56 has the highest level of what? Yeah, iron 56 has the highest number of the binding energy, highest amount of bind. But why? Now, let us go to the fundamental forces of nature, guys. Fundamental forces of nature. In that one of the most important forces is the strong nuclear force, right? Right. So it is the strong nuclear force that holds together, or like strong nuclear force acts between the nucleons. Strong nuclear force acts between the nucleons to keep them together. Some other name is called the binding energy. I hope both are. Binding energy is nothing but a strong nuclear force. I hope that is it. If I am wrong, you please correct me, okay? I hope binding energy is a strong nuclear force, something like a strong nuclear force. Its job is to what? Bind the protons and neutrons together. Protons and neutrons together. Then comes the repulsive forces between protons. Because neutrons, they don't have any repulsive forces because they are neutral charges. Repulsive forces for protons is the electrostatic repulsive forces. Electrostatic, right? It repels away the protons. It repels away the protons because they are like charges, so they repel each other away the protons, right? They repels away the protons. Now the catch for the nuclear to be stable is that these both forces have to be balanced by each other. Okay, there should not be only strong nuclear force and there are no repulsive force. Means there is a possibility of the subatomic particles colliding and collapsing on each other. And there should not only be repulsive forces. If there is no strong nuclear force, then the atom won't exist, right? They repel out each other and protons will be roaming around freely. They cannot be contained in a nuclear force. So the key to stability is the balance between these two forces. And as I said yesterday, as we saw the graph about nuclear stability and everything, this graph, if you see, for lighter elements, the dotted line of n is equal to z. The number of neutrons is equal to the number of protons, right? That line is the line of stability. For lighter elements, when the number of protons is equal to number of neutrons, the nucleus is stable. The nucleus is stable, so no issues. Okay, but as we move towards the heavier and heavier elements in the periodic table, the number of neutrons and protons are not equal. There is an imbalance, but that provides them what? That provides them the stability. Now coming back to here, in this graph we saw here the stability is less, here the stability is less. For iron alone the stability is high. The catch is, as I said already, for elements below iron, the imbalance between the neutrons and the protons has to be what? It is stable, but it is not as stable as that of iron. For elements higher than iron, the number of neutrons proton stability is also not higher. What I mean to say here is, iron has the right proportion of neutrons and protons. Iron has the right proportion of neutrons and protons such that its binding energy and the repulsive forces are balanced almost equally. They are balanced very well, right? So let us say both forces are almost equal, binding energy and the repulsive forces, so that they are very tightly hold. Like imagine if two persons pull a rope from each side, right? Two persons pull a rope. Person A is here, person B is here, right? And they are pulling a rope. I'm sorry. Okay. They are pulling a rope from each other end, right? With the same force F and F. Then the rope stays still. The rope stays still. If even one person increases the force, then the rope and system moves this side. Like the stability is disturbed. It moves to an unstable situation, right? Now let us say this person balances very well, right? Balances very well, and there is a net force of F this side, so the stability moves this side. Okay. In the same way, for this nucleus, binding energy and the repulsive forces for iron, they exactly balance out each other. So removing anything, either the binding energy or the repulsive forces, may compromise in the stability of the nucleus. So in nature, always stability is the matter of concern everywhere, right? So in order to maintain stability, binding energy and the repulsive forces are so much intricately balanced. That's why if you see in one of the previous questions of which is exothermic and endothermic, I hope it's which question it is. Which question? This one. This one, yeah. We showed that a fission of Fe is not possible because binding energy, it is so much balanced by the repulsive forces. So slightly decreasing the binding energy is very difficult for iron. So that is the reason why iron has the maximum binding energy. That is the proportion of neutrons and protons. To put it in a simple statement, the proportion of protons and the proportion of neutrons are in the right proportion, are in the right fraction. So the elements below, where's the graph? The elements below Fe undergo fusion to reach the stability of iron, and elements after Fe undergo fission to attain the stability of iron 56. And it's not any iron, it is particularly iron 56. Iron nuclei having the mass number 56, right number of neutrons and protons. That is why the binding energy per nucleon of iron is maximum for iron, right? Binding energy per nucleon value is maximum for iron because of the right proportions of the neutrons and protons. It's just a very, a logical kind of explanation. But if you want to delve deeper into it, what is the actual reason, you can go ahead with research papers. And if any of you are interested, I can go through some research papers and tell it to you why it is. Even I am interested to know. Okay, so yeah, so already it's known the answer is iron 56. It's just that both these forces are equal or balanced out each other very well. That is it. Okay, why they are balanced, something we still get it. So that's why when you ask questions, you get new theories. That's how Planck got his theory. Why can't we consider energy to be discrete, not continuous? Planck caused his formula. Then what is it? De Broglie thought why can't matter have a dual nature when radiation does? That's what De Broglie thought, and he in fact cleverly used Einstein and Planck's theories to create his own theory, right? Then we have our who's that? The guy who told that a magnetic field can't produce electricity. Oh my god, I forgot. Maybe, yeah. It's a Maxwell. Yeah, it's Maxwell. Yeah, Maxwell. His groundbreaking research. Everything, it's out of curiosity, guys. It's everything out of curiosity. Okay, now let's move on to the 19th question. It's very easy. Now, it's very easy. If it's a live class, you guys have to solve it and I won't, because it's a very easy question. Number of alpha and beta particles emitted uranium-238 to lead-206. Now, forget about uranium, lead and all. A mass number is changed to 238, 206. What is the difference? It is 32. 32 difference. So, for mass number for each alpha particle reduces by 4. So, beta particle does not reduce the mass number, so affect the mass number. So it is totally about alpha particles. So there are 8 alpha particles here, because in 32 there are 8 fours. 32 divided by 4. Each alpha particle decreases the atomic or the mass number by 4. So there is total decrease in 32. Total decrease in mass number 32. So total number of alpha particles released is 8. So which is the option? This is ruled out, this is ruled out. Only 2 options. Now beta minus particles. Now only comes uranium and lead. Okay, uranium, what is the, this is advanced questions. Here they will not give uranium's atomic number or lead's atomic number. You need to know that. That is where advanced questions have a slight edge over mains questions, right? You need to know atomic, because these are very commonly used elements both in industries and in stuff in examinations as well, right? So the atomic number of uranium is 92 and that of lead is 82. 92, 82. It is decreased by 10. We know beta minus particle, right? Beta minus particles are nothing but electrons. And wait, beta minus particles are electrons or positrons? Do you remember? Let me check it out. Yeah, beta minus particles are electrons. But do you see it out, guys? Actually, for beta minus particle, the atomic number should increase, right? Atomic number should increase by 1. But here it is decreasing. I think there's an ambiguity. Let me check 1 minute. Right, here it is not emitted, guys. For beta minus it should be added. There's a mistake in this. So anyways, it will be, since it is 10 it is atomic number is decreased by 10, there must be 6 beta particles or 4 beta particles. For each beta minus particle, alpha and beta minus particles emitted when uranium-238 decays to lead-206, right? 10 means there must be, wait, we are forgetting the fact. Yeah, wait, we are forgetting the fact. Wait, Oh my god, I hope you can still see the screen. Let me check. Yeah, you can. Now see, not only beta minus, alpha particle also contribute to decrease in, it increases by 1, it decreases the atomic number by 2. You got that? You remember? See, we found out there are 8 alpha particles, so decrease will be minus 16. Okay, minus 16. To make this minus 16 into what? A minus 10, because there is actual reduce in atomic number is minus 10, but alpha particles alone give a decrease in decrease in atomic number as minus 16. So the remaining plus 6 should be covered by the beta minus particles, because these beta minus particles increase the atomic number. Alpha particles decrease it by minus 16. Beta minus particles should increase it, so that the final decrease in atomic number is just minus 10. So minus 16 plus 6 equals to plus x equal to minus 10, x is equal to 6. So it must be 6 beta minus particles. See, basically there is a reaction uranium to lead. 8 alpha particles we have found out just by using the mass number. There are 8 alpha particles. So this 8 alpha particles will decrease the atomic number by 16. But atomic number of uranium is 92 and lead is 82. There's only 10 decrease. So but alpha particles decrease it by atomic number by 16. But we need only 10. So we need to add 6 more atomic numbers. For that we use beta minus particles. So each one beta minus particle will increase the atomic number by 1. So we need, to increase it by 6, we need 6 beta minus particles. I hope you understand a small trick. Yeah, this is what you have to, you see the combined effect of alpha and beta minus. So the answer is what? Let me check 1 minute. Yeah, it is A. Let me change the color if possible. Yeah, changed. Yeah, now this question is over. This is A advanced. Sometimes this you will get confused. 20th question, very easy question, JEE Main 2020 question. If the energy of a nuclear reaction is 12 plus 20 milli electron volt, what does it mean? Obviously, if there is a plus sign, it indicates that the energy is released. It's an exothermic reaction, right? It's simple question, guys. It's just simple question. Energy is absorbed is wrong. Binding energy decreases. Since it's a nuclear reaction, you need to check about binding energy. See, it is a plus 20, energy is released for sure. For energy to be released, binding energy should be increased. It's not decreased. Mass of products is greater than mass of reactant. There is nothing to do with mass here. So that is also wrong. There is nothing to do with mass here. Now check about option C alone. Okay. Option C, binding energy of a reactant, it should be greater than binding energy. According to this, binding energy is decreased, right? Binding energy is product is lesser. Since loss in binding energy is manifested as, yesterday we saw a reaction. The loss in binding energy is manifested as output energy. Wait, where it is? The loss in binding energy. Where did I see? I think we found that question regarding some reactions. They gave some reactions and asked which is exothermic or which is spontaneous, something like that. Okay, I'm not able to find it. Let us see. Okay, no issues. Binding energy is decreased, which means binding energy we saw that for the reaction to be spontaneous, it should attain stability, which means product side should have more binding energy. Okay, the product side should have more binding energy, then only the nuclei is more stable, right? It means we have to provide more energy. Energy will not be released. It will become an endothermic reaction. Guys, yeah, if the binding energy of the its binding energy is decreased, there won't be any stability in the reaction. Reactions always tend to, it's not a spontaneous reaction at all first. Binding energy should be increased for it to be spontaneous reaction. Right? It should attain stability. Only then the reaction will happen. But it is towards instability. So this doesn't change. I hope that is the answer. Let me check. Okay? Let me check about this question later and let you know, guys. If you have any difference of opinion in this question, let me know. So yeah, that's for today. This 10 questions. We talked about Planck's theory, de Broglie's theory and all today, and about new derivations also as well. So this is for today. We'll meet in the next set of 10 questions. Okay, next set of 10 questions, and we will move on to more high advanced level questions as well. Right? Fine. Bye bye guys. Bye bye.